Yep, so today we're going to talk about Kubernetes at Depop. My name is Dave Blooman, and I'm platform engineer at Depop here. And our kind of journey to Kubernetes started roughly about like a year ago. We've been working on Kubernetes in production for like the last 7 or so months. And Depop has kind of had like a big change in like scale. We've grown like quite a lot. And Richard mentioned a few of the numbers. So we have like 4 million monthly active users. 120,000 distinct product categories. One of the things that is quite cool, depending on like what time of day it is, but by the time I finish my talk, nearly 2,000 unique products will be created on Depop. So we have really active users, and that is great for us, but it's also challenging from a platform point of view. So Kubernetes was something that we decided to do once Amazon announced the EKS service. But we should talk about like why we're doing EKS, Kubernetes and EKS, because like why would we do that? We had an existing platform, it was working for us. It was very traditional in that it was Packer-based AMIs. We packaged our Scala code, Python code. It worked really well. So why did we need to change from that? And we had also a lot of usage with ECS. So we had like existing container experience. And so for us, we make this change because the scale of our platform started to grow. We went from sort of a couple of dozen services to a lot of services very quickly. And actually, Kubernetes has even accelerated the rate at which we create services. And so we got to the point where we said, why wouldn't we do this? And so we have dozens of services. We have lots of engineering teams. We grew from kind of one API team to multiple different product teams, and they all need to deploy services across Python, Scala, web, and also our own internal services. So when we started to do this, we actually began kind of in, I guess, the basic way, which is we was using Upstart and Docker Run, like no orchestrator, just straight up Docker. And then we started using ECS, and we found that was good, and we decided to migrate to that. And then Kubernetes is kind of the completion of this journey, and whatever is on Hacker News next month is what we'll be moving to. So this is kind of the state of the ecosystem at the moment. We have 80 plus services in production on Kubernetes. Most of these are new services. 80 total services. We have 30 on Kubernetes, and 10 have been created in the last 30 days. So we've been really fortunate that we've had a platform that allows us to grow this fast. And I'd say around 35 of those services have kind of been created since January. So it's been really great for us. And kind of one of the things that we found when we started using Kubernetes is like, it's great, it's a platform, it's really like nice to use for like projects. And this talk is about like that hello world experience you get, right? You start with like the guestbook application, most people do, and you get it working and it's great. But then actually when you start using it, you realize that the platform you have currently is actually going to be a lot better than what Kubernetes offers. So we found that we were missing a lot of the things that we'd solved really well before. So in terms of our IAM story, auto-scaling for a cluster, and ALB support, we were using ALBs in production, and multi-account. So we run 10 AWS accounts at Depop. And what a lot of these things are supported really well in, say, ECS. So again, it was kind of like a difficult choice to say, let's go and invest a huge amount of time into Kubernetes. But there are a lot of third-party solutions that solve this. So Kube2IAM was our kind of solution for that. The kind of ALB ingress controller, recently Amazon shipped Kubernetes 1.13 support, which does come with limited support for the alpha support for the IAM controller, for the ALB ingress controller. But even then, it was kind of a lot of our work for the last like 6 months to get this working to even parity to what we had previously. So we did all that, we got all working, and then we're done, right? Because like we have a relatively straightforward deployment pipeline. Probably most of you have like something similar. We aren't doing anything like really crazy in terms of deployments. We don't have like a really complex CD system. It's pretty much using tools that a lot of people are familiar with, Helm, Kubernetes. And we use ECR to store our images. And so when I'm talking about service, like I think it's important to like kind of break that down. What exactly is a service? And for Depop, a service is a number of like core things for us. And this is on Kubernetes, right? So like we IAM roles for ensuring that you have access to the correct resources. We want log entries, so every single service has the correct log group. We want a pipeline for setting up Terraform appliance. We use Terraform for everything at Depop. So when you create a new service and you want infrastructure that your IAM role is going to use, it's done in Terraform. And also Kubernetes namespace, and we have a service catalog which maintains the state of all of our applications at Depop. So this is all kind of bootstrapped for you when you want a new service. And when we want to take that service to production, there's a lot of other stuff we also need, right? So we need things like secrets, configuration. We need to think about how we're going to deploy this and not have downtime. So things like pod disruption budgets. We want pod auto-scaling. We want DNS to be set up for us automatically. We want metrics, alerts. Everything needs to be set up so as an engineer, I can come to this and say, I want to deploy 50 Scala services or 20 Python services, and they're going to be exactly the same every time, and deliver that quality that we expect and ensure that we don't have downtime. So this is a really important part of the journey that really none of this has anything to do with like Kubernetes in some cases. This is just general good platform, but this is something we had to then redo. And this is something that you step onto when you like say, we have the hello world. Now we're way, way beyond that. We're into like the territory of taking things and putting them in production. So this is one thing that we came to very quickly. And the Kubernetes documentation says like, don't overuse namespaces, right? And what did we do at Depop? We overused namespaces. So we created too many namespaces. It became hard to track things. Spent about a week putting everything into the right namespace once we decided on everything. And actually, we found that once we had this kind of good approach to naming things, I know naming things is hard, but we actually came to like a good way of doing things. And actually now, we're in a position where, as an engineer, I can create a service and have no problem with security. It's in the right namespace. It's around the product group. It's in the right service category. So there's a lot of different naming conventions that we use at Depop to ensure that you're using the right service with the right access. So yeah, ensure that your naming is really, really on point. And to that end, we then package all of our code as Helm charts. And I know there's like a lot of people have kind of looked at Helm, and it can be very useful, but it can also be extremely complicated. A lot of people have like used like conditionals everywhere. It's a very big templating engine. At Depop, we keep things extremely minimal. I'd say like we don't have any, or maybe we have one conditional in our template, and that is for DNS. But apart from that, we keep it very tight so that when you deploy a service, there's really nothing going to be changed apart from the DNS. So it's a great tool that we found, and a lot of people have kind of moved over to customize because it's declarative and much more kind of easy, I guess, in a way to see, know the code you're going to be deploying. For us, we haven't felt the need to do that yet because, again, we have like, minimal Scala templates, Python templates, Node templates, and that's really worked well for us, as opposed to using regular YAML, which it wasn't really going to scale for once we got past like 20 services. So this is kind of a normal values file for us at Depop, and what we do is a number of custom things. So we found that Helm was like not great for a lot of things. And while the templating was good, the actual tool itself has a lot of issues that we wanted to solve. And specifically, again, it comes back to that kind of like idea that we had this really great platform, an experience that everyone expected. Things like rollbacks, status checks, those kind of things. And that wasn't something we were getting from Helm. I think there's like a part of Helm where like if you like force redeploy, it just deletes everything and then recreates it, and it's like that doesn't help at all. Like you're just deleting a production application. So we wrote a very thin wrapper around this called Portyard, which manages all of our Helm deploys, but all of our deploys within Kubernetes, and it does several things. There's rollbacks when you deploy with Helm for the first time. Sometimes that can just break everything. So this automatically deletes the first release if it fails. It does things like download the charts when you update the chart museum. It handles secrets, does a lot of developer mistakes. Copy and paste errors are quite frequent, so we kind of wrote a lot of logic to stop that from happening and breaking everything. A number of times we had services where developers deployed over the top of others and broke a lot of things. And so Portyard kind of has helped us a lot in our kind of journey to improve our existing platform. Again, we want to go and improve the platform experience. So this is kind of a minimalist graph of where we saw the improvement. Now, actually, the first thing you can see is that we actually went up in builds time, in our compile time, I should say, because although we're mostly Scala and it can take sort of 6 to 7 minutes to compile, we actually found that it was easier just to package the Docker part into this section here. So this actually is the compiling and building of the Docker image and the pushing of the image, which is why we don't have anything in this second section. And then the deployment, when you're using Packer and doing rolling updates in CloudFormation, it took us a very long time to deploy. And this reduced dramatically our deployment time, and a lot of people have been very happy with this. And it generally, I think, for all of the services that we've deployed, we've managed to reduce the deployment times. So our kind of first attempt at Kubernetes was like, I think, like if you read any tutorial, that was kind of what we started with. I think that's like good point. But we found that we were quite limited again. We wanted to kind of rebuild the features that we lost when we did that first iteration. And so config, a lot of it was hard-coded. Secrets were injected by our Jenkins rather than using Vault, which we've leaned on pretty hard. So we wanted to build that back out. And the way we did that is, starting with secrets, we use Vault. Vault is a thing. And if I had to do this again, I wouldn't use Vault for like Depop. But like, it's a thing that you have to like keep and look after and everything. And actually, there's a great alternative to like secrets in general, which is the sealed secrets, which is really cool. But for secrets, we decided to go on the approach of we have Vault, it's our point of truth, and we like using Vault for that. Developers have access to put things in Vault. We manage all the secrets, so it's all automated. How do we get them to Kubernetes? Now, a lot of people would then say, well, you can just run a container, connect to Vault, get the secrets, right? Well, the problem with that is it's a runtime dependency. And if Vault is sealed, you can't scale, you can't run new containers. So it's really like not a great situation for us, and actually would degrade the platform that we already have, which is immutable AMIs. So we wrote a tool called Baffle, which replicates the secrets for us. And so in our Helm chart I showed earlier, our values file, we have this path, and this is actually a Vault path. And so the secret is just replicated over at build time. So if, for example, Vault is sealed, then your build fails, but you can just unseal Vault, and then you get your secrets when you've deployed. And this can inject the hash of the secrets so that it rolls the deployment every time a secret changes. This was like quite a simple solution for us, but have really like stopped us from kind of being leaky on secrets and putting them in different places. And it's been a very like easy solution to maintain security over. We also just kind of have started doing implementation for SSM as well, so we can use this for ECS and other services. Just to continue a little bit on the ALB ingress controller, as I mentioned, 1.13 supports the new version of the ALB ingress controller, although this is only version 1.0, and it's not as advanced as the version you can get if you just run it on your own. And this is something that we upgraded to very quickly. Most importantly as well, because when we started, the ELB support means that we were running out of security groups, because every time we created an ELB, it had the security group ingress rule, and you only get 60 on a security group. So that was an important point for us to make sure that we didn't run out of security group ingress rules on our main cluster. So if we go back to this slide that we talked about earlier, where are we deploying to? How do we set up EKS in general? Like, what's the stack look like? And this is kind of like our deployment strategy. So we kind of have this like 4-phase deployment, which is our cloud, which is AWS with EKS, and then everything is terraformed, apart from the few Kubernetes provisioned AWS resources. We then have kind of our platform level deployments, which is managed through EKS. And then we have our service and config releases, which is done at kind of build time, I guess you'd say. And then we finally finish with our code release, which is going to be the thing that actually is implemented in our deployment in Jenkins and is going to deploy our new code. And so this is important because a lot of the time when we first initially started, we found that like we were deploying everything in one big bang, right? Like you change something in a Helm chart, then you change like some config, some secrets, some code, and you have no idea where things break. But actually, we've implemented the platform so we can deploy things separately, leading to much more like stable releases. So the only thing you're changing is code, or you do a secrets release, or you do a config release. Much more reliable that way, rather than relying on sort of dynamic secret injection or that kind of thing, which actually led us to, or has led us to, problems in our platform in the past. So to kind of talk about like the future of what we're planning to do at Depop, we've started recently kind of trying to build out Kubernetes usage across the business. So we run Scala APIs, Python, Node.js. But we've also recently started using for our ETL jobs. So this is Airflow, which is a tool that allows us to run all ETLs. It uses the Kubernetes provisioner, meaning that we don't really have to worry about scaling up in EC2 instances. I think like for this, we may consider using like Spot instances maybe in the future for this, especially if it's like very peaky workloads. But generally, you can ignore the failures as well. So the workload is like pretty good, and we'll see the Kubernetes dashboards, which will show the containers spinning up. And really great to kind of utilize the underlying platform. Again, we get the benefit of all the IAM and secrets and everything that's all in the Helm chart, which has been really useful for us. So next step is to continue migrating our services from our legacy platform now to Kubernetes and ECS and essentially just containerizing everything. And then to improve our config pipelines. So at the moment, for example, we have Terraform, but Terraform doesn't really speak to Kubernetes, right? So how do I get a Terraform value into my Kubernetes container without hard coding it? It's a problem we have, and we want to try and connect those two together so that we can release a version of config with a version of Terraform. And that allows us to, and also other services as well, not just Terraform, but any value we want to inject into Kubernetes, we want a config pipeline that allows us to do that and do kind of immutable config deploys. And finally, kind of looking at the next generation, so service mesh, blue-green deployments, and further into Kubernetes integrations, again, Airflow, but other tools that we want to do that already exist in our infrastructure that maybe we don't want to lean on AWS, but we want to bring into Kubernetes.